Hi, we're Group 10 for Lab 6, and this is Jonathan.
I'm Jaden.
I'm Carter.
All right. So starting off with our process flow, you can see here it goes pretty smoothly through ingredient glaze prep, then dough mixing, then dough forming and cutting, which is not monitored, proofing, so the rising of the dough, frying the first side, and then flipping it over to the second side, but the second side is not monitored. And then the drain and cooling before the glaze, then the glaze prep and holding tank, the conveyor belt through the glaze waterfall, then the post glaze, cooling and inspection, and then the packaging at the end, which is not monitored, but all the ones that I didn't say are monitored, as you can see. Then going through some of the QCs, starting off with process. There were a handful that we decided on, but we decided to cut it down to the top 5. So the most important ones on the process side were glaze temperature, consistency, the pump flow rate, the conveyor belt speed, and then the donut temperature before glaze. And then moving on to the product side of the QCs, again, we thought of quite a few, but the top 5 are the diameter and shape uniformity, the surface smoothness, the moisture level of the donut weight, and then the color and fry level. And then going through with our SPC software that we decided on was Minitab Real-Time SPC. The reason that we chose this one is because it is an industry standard SPC platform designed for phase 2 monitoring, so this exact situation. And then it is able to support all of our major control charts that we have. It continues to track a lot of the variables that we want. And then it does provide a simple dashboard so the operators can monitor multiple QCs at once.
So for the SPC tools that we used an X-bar chart. That was for monitoring the average glaze temperatures. We also used an R chart. That was for monitoring the temperature variation. And then we also decided to use a P chart, and that was just for the percentage of donuts with uneven glaze. We've also used Google Colab to actually do the phase 2 monitoring. We decided that was appropriate because it provides automation, accuracy, and also just easy chart updates. So for our sampling plan and sensitivity, we went with the subgroup of 5. That would have a sampling frequency of every 5 minutes. This would make about 600 donuts per hour, so it does not interfere with production. We also thought this was pretty cost effective. For the phase 1 data setup, we used the first 100 glaze temperature observations, which was 5 groups of 20, and then the X and R charts we thought were sensitive enough to instantly detect a large upward shift in the glaze temperature. So for the phase 1 results, we had 100.73 for the X bar, R was 21.72, and then those are the X and R limits. As you can see, all the phase 1 points were in control, so we kept these limits for phase 2. So moving on to phase 2 results. We did the observations 101 to 150. As you can see, the phase 1 mean was 173. Phase 2 ended up being 120.53. It's about a 19.8 shift. Roughly a 2 sigma mean shift, which SPC correctly detected.
So for the cost analysis and innovation, our daily product assumptions were that we were going to output 600 donuts per hour, and over 8 hours, that's 4,800 donuts per day. Our cost that we assumed for a defective donut was 15 cents. We estimated a defect rate due to uneven glaze at 8%, which is about 384 donuts per day that are defective, which costs us $57.60 every day. After our implementation, we expected our defect rate to drop to 2%. That takes our daily defective donuts down to 96 overall, with a defect cost of $14.40 per day. That results in about a $43.20 savings per day just from reduced glaze defects. Looking at our cost analysis, continuing on, our labor costs from SPC sampling, we sample every 15 minutes, which is 4 times an hour, and we estimate that it takes approximately 5 minutes per round of sampling. Totaling, it's about 20 minutes per hour, over 8 hours, 160 minutes every day. We estimated our labor rate estimate at $20 per hour, which comes out to a cost of $53.40 per day in sampling cost. With our total balance coming to $10 per day more expensive. However, we do believe the sampling cost can be reduced with automation, reduced sampling frequency, as well as digital data collection, which replaces that manual check. Some of the innovations that we think can reduce that cost are real-time temperature sensors in the glaze tank, camera to measure glaze coverage, automatic SPC dashboard fed by sensors, predictive alerts using machine learning, as well as optional automatic heater / pump adjustment to further increase that quality. We expect a more even glaze, less scrap, faster detection, and an overall more stable process. So in conclusion, we designed an SPC system focused on glaze temperature to reduce defects. Our phase 1 charts showed a stable process with valid control limits. Phase 2 charts, we immediately detected a large shift in temperature, proving that our chart was sensitive enough. SPC reduces our defect rates and provides a meaningful cost savings. And our sampling plan is realistic, doesn't slow production, and can be automated. And then with future improvements, we can see that we can make our glaze consistency even better. Thank you.